Hi, this is Prem Kumar, Assistant Professor, Department of CSC, KPR IET. Today we are going to see about classical planning. One of the problem is spare tire problem. So first of all, we are going to see what is classical planning. So classical planning is a subfield of artificial intelligence that focus on the development of automated planning systems that can generate plans or sequences of actions to achieve a particular goal in a well-defined environment. It is based on the idea of presenting a planning problem as a research problem in a state space where each state corresponds to a particular configuration of the environment and each action corresponds to a state transition. It consists of three things. One is planning, another one is acting, another one is learning. So planning is nothing but the agent plans after knowing what is the problem. Acting, it decides what action is has to take. Learning, the actions taken by the agent make him learn new things. So this is about classical planning. So there are four actions used to define the spare tire problem. We are going to see what is spare tire problem. So it is a classical problem in AI and planning that involves a car with a flat tire and a spare tire in a trunk. The goal is to change the flat tire with the spare tire in the shortest possible time using the tools available in the car. So that is the problem. So here there are four actions. One is remove the spare from the trunk, remove the flat spare from the axle, putting the spare on the axle and leave the car unattended overnight. Assume that the car is parked at an unsafe neighborhood. So again, the initial state, actions and preconditions and effects and the goal states are very important to solve the problem. The initial state, the car has a flat tire and a spare tire in the trunk. The actions, we have to remove the flat tire, then we have to install the spare tire. So preconditions and effects, remove the flat tire requires the use of the jack and it changes the state of the car from the having a flat tire to having no tire at all. So installing spare tire also requires the use of jack and it changes the state of the car from having no tire to having a spare tire. So the goal is we have just changed the tire. So that's all the action sequence of this problem. So next we are using this language to implement this idea is PDDL, a planning domain definition language. It is a formal language used for describing planning problems and domain knowledge in AI planning. The spare tire problem can be described in PDDL, which provides a standardized way of representing planning problem that can be used with various planning algorithms. So the components of PDL, initial state, goal state, again in between it has actions and other results and all. So the preconditions, first one is initial state. This represent the starting state of the problem domain. The goal state, again there are three things: at spare tire car, at wrench trunk, at jack trunk. So these are all the goal state. So the algorithm, you can see that the initial conditions, then goal, then actions, then preconditions, then effects, then actions, again another preconditions, effects, actions, again another preconditions at the end state. So these are all the PDLL description for the spare tire problem. The solution problem is very simple. Just we are going to remove the flat and remove the spare and put on spare axle. That's it. So the goal, already I told the goal and other things. Next we are going to see the classical planning algorithms, how it is implemented. So it is implemented using initial, then actions, then again actions and other things. Again same as I said, initial, goal, actions and other things. How the actions the shortest thing. So we are having some pictorial representation. So remove, leave, overnight, remove spare trunk and casual links. Repeat the steps with remove and also add remove flat axle and finish the problem. So this is the main thing. So before ending, I would like to go why it is important, the spare tire problem, why it is important. So the several reasons. The one reason is it is a well-known benchmark problem. Another one is it illustrates key concepts in planning, and it third one is it demonstrates the importance of domain knowledge. And first one is benchmark problem. So the spare tire problem is a classical benchmark problem used in AI planning research to evaluate the performance of different planning algorithms and other things. The key concepts provide a simple and inducive examples of the key concepts in AI planning, such as initial, goal, actions, preconditions, effects, etc. So the domain knowledge, the spare tire problem highlights the importance of domain knowledge in planning. So in order to solve the problem efficiently, the planner needs to know which tool are available, how they can be used, and where they are located. So this knowledge is represented in the domain description and can be used to guide the search for a solution. And it has a practical application. This spare tire problem has some practical applications. While the spare tire problem may seem like a toy problem, it has practical applications in real world planning scenario. For example, it can be used to model the process of changing a tire on a car, which is a common problem that drivers may encounter. So that is one. So overall, the spare tire problem is an important problem in AI plan and planning, because it provides a standardized benchmark problem for evaluating planning algorithms, illustrate key planning concepts, demonstrate the importance of domain knowledge, and has practical applications in a real world scenario. So these are all the reasons we are learning spare tire problem. It's a classical problem. Thank you.